All right. Now, what energy has this body possesses as it is hanging? Now, okay, you may think any of the energies, but this body has potential energy. Why is it having potential energy? Because it is energy that is respect to the height, and it is hanging and it has mass. So we are going to make potential energy very simple. Now, what is potential energy? Potential energy is the energy a body has by virtue of its position with respect to the ground, meaning the height. So potential energy must have the height, must have the mass, and must have gravity, which affect all objects under the surface of the earth. So to determine the potential energy, we are going to first put this body on a balance to determine the mass. So we are going to read the mass. This mass is 55.3 grams, but we need to convert it into kilogram. So it is 55.3 grams. We are going to convert it into kilogram. Then we know that this body hangs. To determine the height, we use a meter rule. So from the ground to where the body is equivalent to 1 meter. Now, we also know that gravity affects it. So since we have determined the mass 55.4 grams, since we know the height, which is 1 meter, and we know the gravity, which is constant, 10 meters per second square, we can multiply all these three quantities to get the potential energy. So from here, we are going to go to how we present our data and arrive at our answer. Don't forget, a mass of 55.4 grams, a height of 1 meter, and acceleration due to gravity, which is 10 meters per second square. Now, we have come down to where we present our data. Now, looking at the data from the experiment we conducted, we find the mass of the body to be 54.4 grams, which is equivalent to 0.0554 kilogram, because you need to convert it to its proper unit. Then the height is 1.0 meter. Then the gravity is 10 meters per second square, which is constant. It is 9.8 meters per second square, but we approximate it to 10 meters per second square. Now let us look at the formula. Potential energy equals to mass times height times gravity. Now, so therefore, M times 8 times J, which is 0.0554 times 1.0 times 10, which will be equivalent to 0.554 joules. Now, the unit is very much important. Here, we are using the capital of the joules, which is J, or you can write the unit and do the spelling, but therefore, you use a small letter for the what? For the unit. So that is how potential energy is